All right, in this video we're going to look at your quiz that just covered sections lessons 1.2 to 1.4. Now the order that my questions are in might be different than the order that yours were in, so you just want to make sure that you pay attention to that. But these are the same questions that you had in your quiz. All right, so for the first one that I have here, it says complete the sentence to describe the transformation of the parent function, y equals, so f of x equals, oops, I forgot to change that. This is supposed to be the square root of x. For the equation below, so obviously the parent function here is the square root of x, not x squared. But since we have a negative outside the parent function, that means it's going to flip over the x-axis. Flipping it over the x-axis is flipping it vertically. And inside the parent function, we have 4 times x. And so if it's inside, it's going to affect the graph horizontally. Remember, that also means that we have to do something with that 4 instead of just leaving it. So in this case, we would take the reciprocal of 4, and we get 1/4. And since 1/4 is between 0 and 1, that means it's a shrink. And again, it's happening inside the parent function, so it's affecting the graph horizontally. All right, so this one, we're looking at the limit of the function. So remember the way this is written, this is referring to the right side of the function. The right side of the function is going infinitely up. Now, some people said that no limit on this side exists. That would be if there's an endpoint, then there would not be a limit on that side. But in this case, there is a limit, and it keeps going up infinitely. So it approaches infinity there. So there is a limit, just that it approaches infinity. And in the left side, the graph, since there's a horizontal asymptote at -4, that means the graph is getting closer and closer to where y is -4. So -4 would be the limit for the left side of the graph. So this one, again, we're looking at a transformation, and so we're going to type in the equation that's going to shift this parent function, y equals absolute value of x. It's going to shift it 8 units to the left and 7 units down. So if it's 8 units to the left, remember that's affecting the graph horizontally, and if it's anything that's happening horizontally, it happens inside the parent function. So inside the absolute value here is where we're going to put this 8. But remember that we have to do the opposite. So even though our brain wants to say that to the left would be negative, that means that we would actually put +8. 8 units to the left would be +8. 7 units down, that's affecting the graph vertically, so that just stays the same. And that's going to go outside the parent function, so it'll be -7. Okay, the key word here for this one is that we're looking for the intervals. We're looking where the graph is increasing. So these choices here are not coordinates, they're intervals. And we're looking to see where it's increasing. So it's increasing until we get to this point, then it's decreasing, then it's increasing between these 2 points, then it's decreasing, then it's increasing here. So there's 3 intervals where it's increasing, the first of which is from -infinity to -7. And then this one goes from where x is -3 to where x is -1. So again, we label our intervals based on the x-axis. So from when x is -3 to when x is -1, it's increasing. So where's that one? That's right here. And then it's also increasing from when x is 2 to infinity. So from 2 to infinity, that's the other interval that it's increasing on. Here we're trying to find the relative minima. So relative minima would be a point where it changes direction. Now it doesn't have to be the lowest point, just for that section. So this graph goes infinitely down, so there is no absolute minimum. But between, or in this section here, we could say that there's a minimum at this point. So that'd be where x is -3, y is -1. But we could also look at this section here and say that there'd be a minimum point right here, and that's where x is 2, y is 1. So those would be your 2 relative minimas for the graph. All right, so this one we're trying to figure out whether it's odd, even, or neither. So to do that, I'm going to do this over here to the right, on the right side. So I'm going to replace x with -x. We'd have -x to the 5th power minus 2 times -x squared. Now, any time we have a negative base with an odd exponent, your answer after we apply the exponent is going to become negative. And anytime we have a negative base and an even exponent, your answer is going to come out positive. So that would come out a positive x squared, but then we still have this -2. So when we compare that to the original, the x to the 5th changed to a -x to the 5th. -2x squared stayed a -2x squared. So since one part changed and one part stayed the same, this is neither even nor odd. In order to be even, they every term would have to stay the same. So everything would have to stay equal. In order to be odd, everything would have to become opposite. So even equals or equivalent, odd opposite. That's an easy way to remember it. All right, so here we're trying to figure out what are the relative maxima. So just like the previous question we saw, this one would be one of our relative maxima if we just focus on that section, and that's where x is -7, y is 2. And this one here would be another relative maximum, and that's where x is -1, y is 5. And there are no other relative maximas because, again, it has to be like a mountain peak where it changes direction, where it goes up and then comes down. So those will be the only two answers for that one. So here we're trying to figure out where is it decreasing. So it's decreasing, and again, the key term there is intervals because these choices are not coordinates, they're intervals. And so from when x is -7 to when x is -3, it's decreasing. And from when x is -1 to when x is 2, it's decreasing. So those will be the only two sections on that graph where it's decreasing. All right, so here we got to determine what's going on here. So since we have just a plain old 4 happening outside the x squared, that's not going to be flipped over the x-axis. There's no reflections there. But the 4, again, the fact that it's happening outside the parent function means that it's affecting the graph vertically. And when it's affecting the graph vertically, we don't have to do anything with it, so we would just say it's stretched vertically by 4. And then with this one, so this one we're trying to find that, so this one is discontinuous because we can't draw these graphs without lifting up our pencil. We see that there is a hole here, so that's where x is 0. There's a hole. And the graph is also discontinuous at the asymptote where x is 2. And it's also discontinuous at the graph, or at the line y equals 3. And again, those are asymptotes. And lastly, for this one has no absolute maximum and no absolute minimum. So there's no absolutes because it goes infinitely up and infinitely down. So there's no highest point where it changes direction. And no lowest point where it changes direction and comes back up again because it goes infinitely up and infinitely down. And lastly, for this one, to figure out if it's odd, even, or neither, we need to do the same thing as we did in this previous problem. Except, so for this one, we're going to have 4. We're going to replace each x with a negative x. We'll have 4 times negative x to the 4th power minus 2 times negative x squared plus 8. So remember, anytime we have an even exponent, it doesn't matter what the base is, your answer will always end up being positive. So negative x to the 4th power would be a positive x to the 4th. And then negative x squared would be a positive x squared. So this will become minus 2, or this will stay minus 2x squared plus 8. So since this function is the same as what we had originally, or equivalent to what we had originally, this would be an even function. So since everything stayed the same, it would be even. And that's actually the last problem. If you notice, it's changed to be next because I had to stop the video. But now that is the end of this lesson, or end of this quiz. So hopefully that answers the questions that you might have had. If you still have any questions on any of those problems, please make sure you reach out to ask so we can get that figured out before you take the test.